Newton's laws of motion. There are three laws of motion which explain motion of an object as resulting from the forces acting on the object. What is a force? An interaction between two objects. For example, pushes and pulls. For example, pushes and pulls are the forces. Here we must be careful to think about a force as acting on one object or from another object or force due to the another object. There are different ways to define the force. Maybe push or pull. That force acting on one object from another object or from another object due to first object. Now we are taking here the concept of forces, adding forces. Forces are the vectors. So we have to add as follows. Since forces are the vectors, they have both magnitude and direction. In one dimension, note the direction using plus or minus sign, then add like scalar quantities. For example, consider here one force is in the forward direction of 3 Newton value. Another force is also in the forward direction having the same value as 3 Newton. Now the additive force of these two is equal to 6 Newton in the same direction. And if we change the situation, first force is 3 Newton in the forward direction, whereas second force in the backward direction as equal to minus 3 Newton, means these two forces are equal in direction and magnitude. Here it is the opposite situation. First force in the forward direction and second one is same in magnitude but the direction is opposite. At that time the additive force is equal to 0 Newton, or maybe it is called as a resultant force. Now, Newton's first law of motion. The statement for that. Consider a body on which no net force acts. Here the word net is important. If the body is at rest, it will remain at rest is one of the possible situations in order to define Newton's first law. Second situation possible, if the body is moving with constant velocity, it will continue to do so. It is the exact statement for Newton's first law. I repeat again. Consider a body on which no net force acts. If the body is at rest, it will remain at rest. If the body is moving with constant velocity, it will continue to do so. It is not that no force at all can act on the body, it is just that all the forces must add to 0. If the body is at rest, it will remain at rest. If the body moving with constant velocity, it will continue to do so. Now we move towards Newton's second law in one dimension. Generally, it is F equal to ma in magnitude. The second law of motion is nothing but the product of mass into acceleration of that particular object. It is in magnitude. While since force is a vector quantity, I am written the same equation as summation of F bar is equal to ma bar. That is, we are showing here magnitude and direction both. Hence, a bar, that is acceleration, is equal to summation f bar upon m. Only forces which act on the object affect the acceleration of the object. It is shown from this equation. The forces exerted by the object on another object Now, here I am taking the example. Taking the example as pushes or pulls. Frictional forces, tension in a string. Suppose gravitational force is here, that is weight equal to mg, where g is the acceleration due to gravity. In SI system, it will equal to 9.8 meter per square second. And normal forces, one object touching the another. These are the varieties of forces: pushes or pulls, frictional force, tension in a string, gravitational force. As you can say, normal forces that is the interaction between two objects. Draw a free body diagram. Now, what do you mean by this? Draw the object, show all the forces acting on that object as vectors pointing in the correct direction. Show that the direction of the acceleration. Choose a coordinate system for that. Translate the free body diagram into an algebraic expression based on Newton's second law. For this, consider an elevator moving downwards and speeding up with an acceleration of 2 meters per second square. Here it is shown that elevator. The mass of the elevator is 100 kg. Now, what should be the tension in that cable? First, we have to identify the forces acting on that elevator. That is due to tension in the cable, weight of the elevator. Now, what will be the free body diagram for this present situation? This free body diagram is, this is an elevator, T is the tension in the string, A is the acceleration acting downwards, and W is equal to force due to gravity, that is elevator. Choose the coordinate system. Let us see plus y direction and minus y direction. It is shown here. It is plus y direction, and before that downward to the elevator it is minus y direction. Now translate the free body diagram into an algebraic expression like T minus W is equal to mass times acceleration. Why this acceleration is shown negative here? Because it is acting in the downward direction. The motion of the elevator is in the downward direction, hence it is shown negative here. From calculation point of view, it will be equal to T minus 100 kg into 9.8 meter per second square is equal to 100 kg into minus 2 meter per second square. This 100 kg and this acceleration is given in the problem itself. Now we move towards third law. Whenever an object A exerts a force on another object, maybe B, the second object exerts a force acting on the first object. It is in this category. One object will act the force on the another object. These forces are always equal in magnitude but opposite in direction, because third law of motion explains as there is equal and opposite reaction. Means, in other words, for every action there is equal and opposite reaction. Such forces are called as Newton's third law force pair. Not all forces that are equal and opposite are third law force pairs. The forces are on different bodies, so do not add to 0. After studying Newton's three laws of motion or laws of motion, in this topic we move towards relativity. How things appear from different frames of reference. Here, laws of physics are the same in any inertial frame of reference. Now the word inertial frame of reference is there. We have to consider here inertial frame of reference. Here I am taking one picture. The law of physics are the same in any inertial frame of reference. What should be these are the passengers sitting in the car. With reference to this, what will be these people observation, or with respect to this, what will be the observation of the front side people. Inertial, now explain inertial frame of reference. There are two types of frames of reference, you can say inertial frame of reference and non-inertial frame of reference. While there is a question of inertial and non-inertial frame of reference, in that one has to calculate the relative quantities like velocity, acceleration and so on. For Newtonian mechanics to work must be an inertial frame. How do you know if you are in inertial frame? Not when in an non-inertial frame you feel forces or accelerations. Hence, add fictitious forces for physics to work as centrifugal forces. Newton chose at rest respect to the distance stars. Means while we are talking about inertial frame of reference, we must consider that particular object in the particular frame of reference. That is, in simple words, frame of reference means the specific location which is allocated for the particular object which is going to perform the motion or further action. Here one specific situation is there. A motor boat and a piece of wood move downstream. Here a motor boat and piece of wood downstream. It is the situation. The boat moves at a distance dBE. Total, the boat is here and it covers the distance from this initial point to this final point as dBE. The distance covered by the boat from its initial position to final position. It is initial position, it is final position. From this end to that end, that distance traveled by that boat is denoted here dBE. Relative to the earth, how one can fix this distance dBE? It is relative to earth, it is the horizontal motion, and hence we are measuring the distance parallel to the horizontal axis. While the wood moves at a distance dWE, this wood, when the boat is at this position, the initial positions of boat and wood will be the same, but the wood flows through this water and stops here, and therefore the distance covered by that wood at a distance only equal to dWE. Now another situation we consider here. A motorboat moving upstream loses the ground through the stream's current if it cannot travel fast enough relative to the water as VBW. It is the situation that boat is here traveling in the direction forward direction and VBE. This direction is VW whereas this is VBW. Thus, this truck platform serves as a rest from for observers A and B, but it moves with the speed V towards observer C, who stands on the roadside. Here there are three students, we can say A, B, C, Now what is the situation of this A and B students? Those two observers A and B moves with velocity v towards the third student C or observer C. This observer C stands on the roadside and these A and B are moving towards that observer with a velocity v. Now laws statements in short shown here. Laws of motion. First law of motion. I am taking the animated picture in order to more clear you the laws. Now for first law, this is the picture. First law, this is the picture. This is one student, you can say it is the object. That object is thrown by the student. Every body remains in a state of rest or uniform motion unless acted upon by a net external force. This body or this object keep at rest. There is no any net force acting on it. If that student pull that object and thrown away, means that student exerts some force on that object and throws away. At that time there is a motion. It is first law. Second, F equal to ma, that is second law of motion. Amount of acceleration of a body is proportional to the acting force and inversely proportional to the mass of the body. It is shown here, an elephant, one student is here or one boy is here, he is pushing to the elephant. Therefore, this acceleration or the speed or the distance travelled by this elephant with respect to the applied force through this boy is A, mass of this elephant is m, and therefore F will be equal to ma. Now third law. It is a picture for understanding third law. For every action there is an equal but opposite reaction. If an object A, suppose this, exerts a force on B, then object B will exert an equal but opposite force on A, and therefore these two things balances one another. Suppose it is A, it is B, then these two are balancing one another. It is a picture for the clearing the idea of second law of motion, that is force equal to mv shown is here. Then the time derivative of v is equal to velocity, and therefore f is equal to, this is F, force applied by that person on that object, is its mass m, velocity v, and therefore f is equal to m times dv by dt. With the equation is valid for this. Now the summary of this article. Newton's laws of motion. Integrating, we are studying here the expressions, statements. Newton's laws of motion relate an object's motion to the forces acting on it. Then we are calling about the first law. Then an object will not change its motion unless the force acts on it. That is the very short definition for or statement for first law. An object will not change its motion unless force acts on it. Now second, the force on an object is equal to its mass times its acceleration. It is the simplest statement for the second law. Now for third, for every action there is equal and opposite reaction. Hence there is a balancing. For example, table kept on floor, vehicle is in the parking space, and so on. Inertial, the question is here, inertial and non-inertial frames. When we are talking about the relativity, we should know the concepts of inertial and non-inertial reference frames. An inertial frame of reference is a frame of reference in which law of inertia and other physics laws are valid. Now, law of inertia means Newton's first law of motion. Another name of first law of motion is law of inertia. Now, one particular type of reference frame, when we are calling it as the inertial frame, in which the law of inertia and other laws valid. A frame moving with a constant velocity relative to the another frame is also known as inertial frame of reference. It is this total is about inertial frame of reference. In an inertial frame of reference, Newton's law of inertia and other physics laws are valid. Any frame moving at constant velocity relative to another frame is also an inertial frame of reference. It is sometimes useful to work in non-inertial frames relative to the inertial frame. You know that about the equation. An inertial frame of reference is a frame of reference that is undergoing acceleration with respect to inertial frame. Now, while we are talking about the non-inertial frame of reference, what will be the exact situation for that? A non-inertial frame of reference is a frame of reference that is undergoing acceleration with respect to inertial frame of reference. It is about today's lecture.